In my previous video, we talked about the differences between a virtual machine and a container. If you haven't checked that video out, what are you waiting for? Go check it out. In that video, we established that containers are lightweight software packages containing all required dependencies. One thing though, I didn't mention in that video and is essential for containers to work in Linux is going to be namespaces. Not sure what a namespace is? Well, you're in the right place. This is B from TatOG Tech, and today I'm going to explain to you what the heck a Linux namespace is. So stick with me. I've got a favor to ask. If you like this type of video and want to see more content like it, make sure to subscribe and hit the bell button for notifications. Also, don't forget to give this video a like if you like it. Let me know what you liked, didn't like, or if you have any comments, questions, or concerns down in the comment section below. And also, don't forget about those emotional outbursts. All right, and so make sure you stick around all the way to the end to get the most out of this video. Let's do this thing. All right, so let's go ahead and start talking about Linux namespaces here. All right, so what is a Linux namespace? Namespaces, or what you'll hear also used when referring to them as kernel namespaces, are what allow containers to be a thing. Now, they have been a part of Linux actually since 2002 and are also present in Unix and Windows. They actually go really far back on Unix, I think to like the 70s, I think is when it was, 70s, maybe even earlier. I'm not 100% certain on the exact date. If you know, let me know down in the comment section below. Namespaces are a feature of the Linux kernel that allows for segmentation of kernel resources. Essentially, what this means is the kernel is able to isolate processes from one another. These different sets of processes exist on the same system but know nothing about one another. And that's exactly what a container does. It runs on the host operating system, but is completely separate from it and everything else on the system, at least as far as the container is concerned. Now, you can think of containers kind of like sharing an apartment with like 4 other people, but you never come into contact with the other 3 people, even though you guys live and share the same space. So that's the way that I like to think of it. Now, through this approach, though this approach may not be best for a roommate situation, it's great for servers who are running many different services and applications as container, like at least from a security perspective. Now, there are multiple types of namespaces, but I want to go ahead and just give you a visual example of what I'm talking about to illustrate the concept of namespaces. So I'm going to go ahead and we're going to shrink this down. I think it's about right. I'm going to bring up my little drawing pad here, aka my iPad. All right. So let's go ahead and go over an example. So you're gonna have the parent namespace, which is going to be this. In this case, will be the system that we're on. Let's just put the parent up here. All right, and then we're gonna have We're gonna have 2 different processes that are going to exist within the parent namespace. We're gonna have process 1. And PID is just process ID 1. And let's go ahead and do that. And then we're also going to have process ID 2. And what we're going to go ahead and do is we have these 2 processes. What we're going to do is we're going to go ahead and put a little box here around this one. All right, what we're going to do is we're going to go ahead and spawn another process within that process, and we're going to go ahead and give it PID 1. So really, what's happened here is we've gone ahead and started a new set of processes within another process within our parent namespace. So these are actually 2 separate namespaces. We have this parent namespace right here, and then we can just call this one like the child namespaces. And if you're not sure about the spelling, namespaces is NAME spaces, just like that. So yeah, and that right there is an example. So let's actually now go ahead and start talking about the types of namespaces that are available within Linux. So I'm going to go ahead and I'm going to trash this. I'm just going to be putting these on the board here. All right. So As far as namespaces go, is you can get namespaces. Oh, let me actually show you something here first before we actually get into that, and I completely forgot about this. All right, what we're going to do is we're going to go ahead and let me just shrink that down. And you can actually get the namespaces your OS currently supports with the ls. Actually, I'm going to do this. Just ls and s command. There we go. And we can see here that we've got 1, 2, 3, 4, 5, 6, 7, and 8. And that's actually what we're going to go ahead and go over now. So we're going to go ahead and actually talk about the different namespaces within Linux. And this is only meant to be an introduction. I'm not going to be giving you the ins and outs of every single one of these, but I do want to be able to go ahead and just let you know just a brief bit about what these are. So let's go ahead and bring back the iPad here. All right, so the first one is going to be mount. Actually, you know what? We're going to call that one MNT because that's how you'll usually see it referenced as. And if you look closely at the output that we had, you'll be able to see that. And I'll actually go back to that once we are done actually going over the different types here. So the first one's going to be mount, which is represented by MNT. This allows for mount points for drives and file systems to be isolated from one another. This is similar to chroot. I actually did a video on chroot, which is basically where you're setting up an isolated environment for someone to go into. That's the same kind of concept there. So go check out that video if you are curious about the topic of chroot, or as what I like to call the Linux jail. Now, process ID, this is going to be the second one. And this one's going to be represented by PID. All right, there we go. And with the process ID, this provides a process within an independent set of process IDs. This allows for the process ID to start back over. So one of the things that you may not be familiar with is the way that Linux systems start. Now, depending on the type of system that you have running, it could be either system V in it or system D. But if you're running system V, the first process is going to be init, and then on the system D system, it's going to be system D. So that's like the very first process, and then everything else sprouts out from there in a tree. And honestly, this is probably a video that I do plan on covering at some point in time in the future, just to give you a better understanding of how the Linux boot process works, starts and all that kind of stuff. But yeah, that's what happens is it spawns all those additional processes. So basically, what we're doing is we're starting from process one within another process, which is exactly what we saw inside of the example we just went over. Now, the next one is going to be network. All right, and this basically allows you to virtualize the network stack. Each namespace will have its own routing table, set of IP addresses, socket listing, connection tracking table, firewall, and other network resources. This is something that you'll see within containers and things like that. So now the next one is going to be inter-process communication. Also known as IPC. Our inter-process communication it allows us to isolate inter-process communication resources. And really, inter-process communications is just one process communicating with another process. That's another topic that I do plan on covering at some point in time in the future once I get around to it. So we'll go ahead and make sure you're subscribed for that. Now, the next one is going to be Unix. Whoops. Time sharing, also known as UTS. All right, and with Unix, time sharing, this allows the segmentation of host name and domain names. This allows for a single system to appear with different host and domain names for different processes. So, it's how, again, this goes back to a container. If we're looking from that perspective, it's going to allow it to have a different host name than the actual host system. So pretty cool. Now, the next one is going to be the user ID, or UID, which you should be familiar with if you've seen some of my past videos. User ID, this is Namespaces linked to user and group IDs. This is just like the user group IDs that I've mentioned in previous videos, the stuff that we're looking at in the Etsy passwd file, or the Etsy group file. So that's what that's in reference to. Then we're going to go ahead and do the next one. Second to last, it's going to be control groups. You hear these referred to as C groups, and are one of the probably most important namespaces when it comes to containers. Now, what this means is it's a means of controlling access to system resources. Again, this is at what makes the heart. This is at the heart of what makes a container a container. It's being able to limit the and moderate the resource access that container has. Because you definitely don't want to set up a container that it's using 100% of all of your system resources, because that's just not going to be helpful for you as a system administrator. So now the last one is going to be, and it gets a little confusing because it's just called time. All right, and time allows you to allows processes to see different system times. Say maybe you have a server that's a container that's serving, I don't know, let's just say the United Kingdom, which is I think they're 6 hours behind the United States, at least in the Central Time Zone. So you may want that you may have that container running on was it GMT time? I think is what they call it, GMT time. So yeah, you may have it running on GMT time, whereas your host system is running on US Central Time. So it's going to allow that to happen. So cool, right? Now, after that, we can see that namespaces are super essential. I did add the super in there to the essential for containers. I do plan on covering more container content in the future, so make sure you are subscribed for that. Check out my virtualization playlist if you're not caught up. But if you are caught up, check out this other video instead. Thank you so. Can't forget the reminder. Remember, mistakes make you better, so keep on making them. Thank you so much for watching my video, and have the greatest of days.